Welcome to the Explainer. Today, we're actually going on a bit of a cosmic detective hunt. We're going to start right here in Earth's surprisingly chaotic neighborhood, and then we're zooming way, way out into the deepest, oldest corners of our solar system to see exactly what's hiding out there.
Okay, let's dive into this. If you look up at the night sky, the answer to this seems completely obvious, right? Just the one big, beautiful, tide-pulling moon. But the reality is that Earth is currently being tagged along by several secret, hidden space rocks. We aren't just flying solo through the void. We actually have a whole secret entourage of intrusive cosmic companions. And honestly, astronomers are really only just beginning to track them all down.
To wrap our heads around these companions, we need to talk about quasimoons. So a quasimoon is a space rock that is technically orbiting the sun, but it just so happens to do it in almost perfect sync with Earth. It's kind of like, imagine running a marathon and having another runner keeping your exact pace right in the next lane. From our perspective down here on Earth, it looks like these rocks are scribbling lazy, chaotic loops around us. But actually, scratch that. It's an orbital illusion. It's just a really delicate one-to-one resonance with our planet's path around the sun. Astronomers categorize all this orbital chaos into a few distinct types. First up, you've got a mini-moon. This is a rock that actually gets temporarily captured by Earth's gravity. Then, a quasimoon, as we just mentioned, is further out, perfectly syncing its solar orbit with ours. And then you have these wild horseshoe orbiters. These are like undercover cops tailing you in traffic. They swing way ahead of Earth, slow down, and drift right behind us in this massive horseshoe pattern. I mean, it is a wildly dynamic environment out there.
Now, you might be wondering, why don't we just pull these rocks in and crash them right into the atmosphere? Well, it all comes down to something called the Hill sphere. Think of the Hill sphere as a 1 million mile invisible bubble around Earth, where our gravity is the absolute boss. Our actual permanent moon is sitting very comfortably inside this bubble, right around 239,000 miles away. But quasimoons? No. They are hanging out millions of miles away in deep space, completely outside that bubble, out where the sun's gravity reigns supreme.
Let's look at some spectacular recent examples of these cosmic freeloaders. At the end of 2024, a rock named 2024 PT5 dipped inside our Hill sphere and became a legit mini-moon for 2 whole months before speeding off, essentially ghosting us. Then there's 2025 PN7. It's a tiny 62-foot quasi-moon, roughly the length of a bowling lane, that's been pacing us for 6 decades now. But maybe the most fascinating one is Kamoa-Leva. Get this, its light reflection matches the Apollo lunar samples perfectly. Yeah, some scientists believe this quasimoon might literally be a leftover chunk of our very own moon, blasted off during some ancient impact. How crazy is that? Section 1, a time capsule named Bennu. Now, what's really interesting here is the number 121.6. That is the exact number of grams of extraterrestrial material the OSIRIS-REx spacecraft successfully returned to Earth from the asteroid Bennu in September 2023. It's the absolute largest asteroid sample ever delivered to our planet, and let me tell you, it is actively rewriting the textbooks on how our solar system and potentially life itself actually began. The moment that capsule landed, researchers treated it like the ultimate cosmic treasure. It was immediately curated under a super strict nitrogen atmosphere. And why do that? Because our atmosphere is completely full of moisture and earthly biology. By keeping it totally isolated, scientists absolutely guaranteed that the chemical signatures found on these rocks weren't just contamination from Earth. What we're looking at is a 100% pure, untouched window into our origins, formed billions of years ago. The astrobiology discoveries hidden inside that pristine dust are honestly staggering. The sample contained 14 of the 20 amino acids that life on Earth uses to build proteins. Even more incredibly, it contained all 5 nucleobases required to encode genetic information for DNA and RNA. You add in evaporate salt minerals and exceptionally high levels of ammonia, and you literally have the essential building blocks required to activate biology just sitting there in a handful of dust. But where did Bennu get these ingredients in the first place? Well, by comparing Bennu to meteorites that have naturally fallen to Earth, like the famous Murchison meteorite, scientists noticed a massive difference. Bennu has a significantly lower ratio of purines to pyrimidines. This unique chemical signature tells us that the ancient parent body, the one that eventually broke apart to form Bennu, actually originated way out in the extremely cold outermost disk of the early solar system. We're talking temperatures plunging to minus 400 degrees Fahrenheit.
which leads to this absolutely profound realization, perfectly captured by NASA's Danny Glavin. Objects that formed far from the sun could have been an important source of the raw ingredients for life throughout the solar system. I mean, really think about that for a second. The raw, complex organic materials necessary for life were being actively synthesized in the freezing depths of deep space, long before planet Earth was even fully formed.
The real key to that deep space synthesis? Water. Remember those evaporate salts we just mentioned? They prove that deep inside Bennu's massive ancestor, there were insulated underground pockets of liquid alkaline saltwater. Scientists literally call this a hydrothermal broth. For thousands of years, this warm, mineral-rich broth just percolated inside a giant asteroid, facilitating all those complex organic reactions that cooked up the amino acids and DNA bases we found in that 121.6-gram sample today.
Let's move on and see how this builds in Section 2, Chasing Deep Space Mysteries. We are, without a doubt, living in a golden age of space exploration, and one of the most exciting active missions right now is the Psyche spacecraft. In May of 2026, Psyche executed a supercritical gravity-assist flyby of Mars, capturing these stunning, high-resolution images of the Martian surface, like the massive Huygens crater, right along the way. Using that momentum, it is now making a beeline straight for the main asteroid belt, aiming for a scheduled arrival in August of 2029. That'll kick off a prime 26-month mapping mission, ending in November 2031. So why are we spending years and billions of dollars flying a spacecraft to an asteroid named 16 Psyche? Because 16 Psyche is a colossal 173-mile-wide, metal-rich M-type asteroid. Scientists believe this isn't just any regular asteroid, but the exposed iron core of a violent, ancient protoplanet. Billions of years ago, a massive collision could have stripped away its rocky mantle and crust, leaving literally only the metallic heart behind. It offers this totally unique, one-of-a-kind window into the unseeable interior of rocky worlds, very much including our own Earth.
When the spacecraft finally arrives, its magnetometer and gamma-ray spectrometers are going to tackle some massive scientific mysteries. One of the biggest questions on the table is, if this really was a molten planetary core, did it solidify from the inside out or from the outside in? I mean, how do craters even form on a world made of solid metal instead of rock or ice? The data we get back is going to fundamentally change our entire understanding of planetary formation. And while these probes travel to their primary targets, they're out there doing incredible bonus science. For example, in November 2025, a rare interstellar comet named 3I/Atlas zipped right through our solar system. In a literal once-in-a-lifetime alignment, it passed perfectly between NASA's Europa Clipper and the European Space Agency's JUICE spacecraft. Simultaneously, Clipper captured scattered dust on the comet's night side, while JUICE imaged glowing escaping gas on its day side. It was just a stunning demonstration of how dynamic and opportunistic our deep space network has really become. What all of this incredible data tells us is that our cosmic neighborhood is absolutely teeming with secrets. The void of space isn't empty or static. It is wildly dynamic. We've got fake quasi-moons tracing our planetary path. We've got chunks of our own moon disguised as asteroids, and ancient hydrothermal space broths delivering the precise chemical precursors for life right to our doorstep. As we look forward to the upcoming arrivals of missions like Psyche, I want to leave you with this thought to ponder. We just saw how a mere 121 grams of carbon-rich dust from Bennu completely revolutionized our understanding of biology's origins. So, if a handful of dust holds the secrets of life, what in the universe are we going to find when we finally map an entire world made of solid metal? Thank you so much for exploring with me today on The Explainer, and keep your eyes on the stars.